Okay, so the second part of the lecture series is on system properties. Again, the way I've organized this is I go through some definitions, and then I talk about the assignments, and then in the next section I go through a food system example in a little more detail. So, properties of systems. Properties of systems include things like persistence, resilience, sustainability. Again, this is related to what I said about why we're learning this. And system properties are different from the properties of individuals or even the specific relationships between individuals or elements of the system. And the name for this is what we call emergent properties. So those are properties of the systems that are not properties of its parts. So, for example, with an ecosystem, an ecological system, you have function, you have a scale of ecosystem which is going to be different whether you're considering, you know, grizzly species or whether you're considering small bird species which maybe only have a much more limited territory. Of course, migratory bird species become a very large ecosystem. Those are all properties of the system. One of the very foundational properties is coherence. And I'm going to go through a definition for coherence, and then energy and entropy, the way we use them in systems thinking, and then talk about some of those sustainable systems properties. Okay, let me just check. I think I'm going to just say what coherence is right here. Coherence is the property of a system that makes it a system. That sounds really very abstract, but I'm trying to think of an example of like a new system. Say I decide I'm going to start a new nonprofit, and I, you know, sitting alone, I write the Constitution and I do a set of bylaws, and then I look for board members, and we have obviously we have a mission. That's why I needed that to write the Constitution. We have a mission, and so with the start of that one element, then a set of relationships between that society and any staff it has and any clients or the people who receive the services and funders, you know, you'll start to get the element and the boxes and arrows and the flow of things like services and money. And to the extent that those things function and become a system with the purpose of, say, ensuring food distribution, say it's a food bank, that circle of relationships, that's the coherence of the system. As long as those things hold together, it's a coherent system. And when it ceases to function for that mission, it no longer has that property of coherence, which is its holding togetherness. There. Holding togetherness. Excellent, excellent definition. People will talk about energy and entropy of systems. And those words are usually metaphorically borrowed from physics. So systems require some energy to function, some energy to maintain their coherence. Human systems typically require human energy, time, work, money, those forms of human energy. And without that kind of energy, entropy will set in, and entropy is the tendency of things to fall apart. So if in my food bank example, say I'm the grant writer and I quit writing grants, that there'll be that would interrupt the flow of that system. And unless another person stepped in to provide that energy, that system might well fall apart through entropy. So you can I'll use another example just of friendship, network systems, friendship systems. Friendship systems require a different kind of energy. They require usually the time, compassion, affection, those kinds of energy. And without that kind of energy being put into a friendship system, it will tend to fall apart. Those relationships won't be maintained and the system will kind of break up and possibly new systems will form. So the same kind of principles extend to any kind of social network kind of organization. Without that some form of energy, the system will fall apart. The energy in a social network system, and this is really important in communities, could be the energy required to bring people together, especially in times where we tend to all be sitting watching Netflix in the basement. There might be some energy or some push required to sort of force us to form new relationships. So especially when communities are changing due to various kinds of in-migration, social networks don't just form between two groups without some impulse that brings them together. So in communities, often that's something around children's activities, which provides the push to get people to put their shoes on and go out of the house and go form social networks in support of their kids. And so then, are the relationships that are formed through those kinds of kid activities enough to ensure that those networks remain available for other social purposes? Is a question. I already defined entropy. Entropy can occur in a human social system if neither personal interest or the perception of consequence are enough to keep the level of investment going that's required. I guess we all have friends that require more time and investment than some other friends require, or at least I do. So there can be just various things that happen in your life that you're no longer able to make those kinds of investments in those particular relationships. And then, in terms of networks, they might just kind of fall apart. So what I've asked you to do this week is to draw a system of one of the kinds that Meadows talks about in the first two chapters, and put a few instructions about this. A system diagram should illustrate some elements, some pieces of the system, and some relationships that, for that transfer of energy, whatever that energy is. So typically elements are boxes or circles, and the arrows are for whatever the feedbacks or energies are that are being exchanged. When you start to think about your system and start trying to draw it out, you'll need to determine what its boundaries are and how big it is. Are you dealing with a migratory bird system, or are you dealing with a garden system? So and I've assigned this as another Google Doc. And to me, this is important for the whole class to learn the learning system that this class is. I want us to all see each other's work on this because of the way that different people see systems. It's easiest to learn that when you look at how other people see systems. So that's why we're doing the Google Doc again this week. There is the optional reading. If you probably will have thought of 100 examples while you read the Meadows reading, and she certainly gives quite a few. So you just need to pick one to draw and draw it and somehow get that on the Google Doc. So what I did for my example was I drew on a big piece of paper. It took me a couple of tries to get something that I thought I could draw, and I thought I could draw and take a picture of, but that's how I did it. You can also use, of course, the drawing tools on Google Docs, but that's a little awkward. So here's my example of excellent drawing and excellent photography. So first I was thinking about toilet paper stocks. and what made me think about that as I was reading the Meadows was her example of the stock of cars on the lot. But what I was thinking about the toilet paper stocks is that there was never any real shortage of toilet paper. It's just that a lot of people couldn't get toilet paper all of a sudden. And so anyway, so I drew a sort of a stock system that's kind of modeled on what Meadows talked about in the car delivery example. And then I was trying to communicate how that changed back in March, when suddenly there was no toilet paper on any of the grocery store shelves. I'd like to say there still was in Kasler, but there was not any in Nelson. So I did a combination of the system, and then I tried to indicate in red what happened. And then I did a sort of a time series, which is like how Meadows pictures some of her examples by time series. So I did both because I'm an overachiever and I wanted to make sure I got all the points. So I put that on the shared Google Doc just to communicate that I'm not going to need you to get out the oil paints or anything like that. This is a sketch, and try to figure out what you're learning from the Meadows and try to put it down on paper. So I think that's it for this section. I'm getting better at these short things. I'll return whenever you press play on the next lecture. Where's my record? Thanks.